But there is one more spectrum we are going to study, which is called absorption spectrum. But first we are going to talk about what does absorption mean. Absorption. This is the atomic energy levels of hydrogen atom. Lowest energy level is called ground state, remember? E1. What is the energy of E1? Negative 13.6 electron volt. This is the energy level of hydrogen atom. Lowest energy level is negative 13.6 electron volt. Second energy level, which is known as first excited state, negative 3.4 electron volt. Next energy level, negative 1.51. Next one, negative 0.85. Next one, negative 544 electron volt, so on. When energy levels increases, this energy also increases from negative 13.6 to other numbers. Finally, it becomes 0. But this energy level diagram can be redefined according to 0. Yani, studying with negative numbers are not easy for sometimes students. For example, if I ask you, what is the difference between these two energy levels? Because there are negatives, generally you struggle with it. Instead of studying the energy levels with negative numbers, let's make the ground state 0 and define others according to the ground state. Because we define others according to the ground state again in here. How can I make the ground state 0? By adding? Yes. By adding 13.6, I can make ground state 0. But I have to add 13.6 for each of them. For this one, for this one, for this one, I add them all. When I add them all, I'm going to get energy level diagram for hydrogen atom, but in a different way. But no difference. Still difference between these two is going to be 10.2. Also here is 10.2. Because we care about the difference in the energy levels when light is emitting, atom is emitting light. We don't care what is this exactly, what is that exactly, what is difference is important for us. That's why defining energy level this way is much easier to answer the questions. Then it is defined as ground level state is 0 electron volt. First energy level, second energy level, which is the first excited state, is 10.2. Second excited state is 12.09, and so on. It goes on this way. And remember, I told you that an atom can gain energy by 3 ways. One of them I explained: pass electric current through the gas, and we did this. There's one more method. Instead of passing an electric current, send photon. Yani, there is a gas inside a container and shine another light through this gas. Pass photons through the gas. Atoms can also observe photons. This diagram is going to be used to know possible energy of photon which can be observed by hydrogen atom. For example, normally electron of the hydrogen is at the ground state, correct? Which is 0. If I want to take this electron from 0 to first excited state, I have to send a photon whose energy is how much? 10.2 electron volt. If a photon of 10.2 electron volt energy is sent through the hydrogen gas, so electron of the hydrogen gas will be taken from ground state to first excited state, or second energy level. If you send a photon whose energy is 12.09, you will take electron from ground state to second excited state, or which is called third energy level. Yani, energy of the photon must match exactly this number. If it is say that 10 electron volt, no, it must be 10.2 photon. The incoming photon must have 10.2 electron volt, 12.09 electron volt, 12.75 electron volt, or 13.05 electron. Not different than that. Not different. So only photons whose energy matches energy separation between two levels can be observed by an atom. Yani, what is the energy separation between these two? 10.2. What is the energy separation between these two? Between these two? Yes. In this case, photon can give energy to an atom. But electric current is not like this. We didn't count this. Any energy can be given to the atom by collision of electrons with other atoms of that gas. But photons must exactly match this difference. Whatever this difference is, in fact, the same difference in here, but we made it a little more understandable by doing this way. Only photons whose energy is equal to difference between the energy levels can be observed by an atom, by atoms. Okay, now let's solve a problem about this. This energy level diagram in the figure shows first 5 energy level for mercury vapor. The energy level of the E1 is defined as 0. Then we define other energy levels according to this. What is the frequency of the emitted photon? Again, question about F. Emitted photon. When electron drops from energy level E3 to energy level E2, yani this is initial. Initial is E3. Final is E2. Calculate the emitted photon and the frequency of the emitted photon. What is the equation for calculating energy of photon? Initial, energy initial minus energy final. Energy of photon is energy initial final is energy final. Energy initial is E3. Energy final is E2. Energy of photon is H times I. How can we calculate F? Divide both sides by H, divide both sides by H. So you will get frequency of the photon as E3 minus E2 divided by H. First find E3 minus E2 in electron volts. E3 is, just check E3, how much? E3, 4.86. E2, 4.66. Subtract them, 4.86 minus 4.66. Of course, this is the difference in electron volt. Convert it to the joule by multiplying 1.6 times 10⁻⁹. Divide by the Planck's constant. This is the energy of the photon emitted from this transition.
Should we memorize these?
No, never.
They were gonna be good.
Is it different for every atom?
Yes. These energy levels are different for every different atom.
That's why they have different
Spectrums, yeah, different lines. But now we go a little further about the absorption. Yes. Atoms can absorb photon. Only photon must have an energy which is equal to energy separation between the atomic energy level of that gas. This is a light which produces continuous spectrum. Yani all colors exist in here. This, of course, every color corresponds to energy, you know that?
Yeah.
Every photon. So exist all visible lights you can imagine. Billions of photons at different energies are shining on a gas. Of course, this gas has some energy separation between energy levels. So then, what does it mean? This gas will absorb some photons. Some of them. Only the photons whose energy is equal to energy separation between the energy levels of this gas. So when these photons are absorbed, what about the rest? They will pass. They will directly pass through the gas. When they pass through the gas and make it passing through a diffraction grating or prism, so you are going to see again a spectrum, but this time you are going to see that there are some dark areas. What does this dark mean? These are the place of the absorbed photon. Because they are absorbed by the gas, they cannot pass. If they cannot pass, their place will appear as dark. This spectrum of light is known as absorption spectrum of that gas. Because this gas absorbs those photons. When light of continuous spectrum, as you see it's continuous, every color exists, shines on an atomic gas, say it's hydrogen for example, hydrogen. Some photons will be trapped, will be absorbed, but photons whose energy matches the energy separation between the energy levels of the hydrogen atom will be absorbed by this gas. They will be trapped. They cannot pass. But all other photons will pass. And when they pass through a prism on the screen, we are going to observe a spectrum of light from violet to red. But some dark lines will be observed as well. These dark lines, the position of the observed photon appears dark in this continuous spectrum. These dark lines form absorption spectrum of that gas. This is absorption spectrum of that gas. Because this gas traps those photons. That's all. Okay, like this. This is the absorption spectrum of hydrogen. When you pass a continuous spectrum through this hydrogen, 1, 2, 3, 4 dark lines. Oh, 4 dark lines. Because hydrogen has 4 bright lines as well. What does it mean? Absorption spectrum and emission spectrum coincide. Because if a gas is able to emit this energy, so which means it can also absorb the same energy. It can also absorb the same energy. Because separation determines how energy of the emitted photon is. At the same time, separation between energy levels determines which photon can be observed. So that's why absorption spectrum of a gas and emission spectrum of the gas coincide. Each line in the absorption spectrum of a given element coincides with a line in the emission spectrum of the element. Observed, emitted, observed, emitted, observed, emitted, observed, emitted. Every observed photon excites electron to higher energy level. Then this electron transits to the original energy level and emits a photon identical to observed photon, of course. This is the observation spectrum of helium. But here is more photons are observed, as you see. In hydrogen, just 4, but in helium, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 dark lines exist, 12 photons are absorbed. Now look at the emission spectrum of the helium again, 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Yani number of lines in absorption spectrum and number of lines in the emission spectrum coincide. Okay? Okay.
Teacher,
Yes.
so if it absorbs the light, how does it emit it?
Oh, so when it absorbs the light, what happens? Electrons are going upper energy levels, yeah?
Okay.
They will turn back again ground state. When they are turning back ground state, they emit it. Okay. So, but, however, in practice, yani in here when we check them, we observe that there are four absorption lines, 4 emission lines. For many gases, more emission lines are usually seen than absorption line. For many gases, it's like this. For hydrogen, because visible is very limited, but for many gases, more emission lines are usually seen than absorption line. Yani multiple transitions are possible on the way back. When the electrons are turning back to the ground state, multiple transitions are possible. Like what? I will explain by a question. How many spectral lines, different spectral lines could be emitted if mercury vapor were excited by a photon, by photons with 6.67 electron volts? Yeah, we are shining a light on mercury vapor. These lights photon have an energy, how much? 6.67 electron volts. And of course this diagram will be given to you. Now, according to this diagram, tell me, electron excites from ground state to which energy level? Check it. 6.67. Which one 6.67? This 0. This 460. This 486. This 546. This 667. Yani when this photon is shining on the mercury vapor, electron will jump from ground state to 5th energy level. So direct jump. So the observed photon with 6.67 electron excites the this mercury vapor atom from E1 to E5. Then this electron will turn back to the ground state, but it can turn back possible. I'm talking about possibilities. It can turn back directly, 5 to 1. Yes, but maybe it will turn back from 5 to 2, maybe 5 to 3, maybe 5 to 4. How many possible lines in this transition from 5th energy level? 1, 2, 3, 4. 4 lines possible in here, but after it transits from 5 to 4, it can continue. 4 to 1, yes. 4 to 2, yes. 4 to 3, yes. How many additional lines? 3. From 3, it can continue. 3 to 1, 3 to 2. 2 additional lines. From 2, it can continue. 2 to 1, 1 additional lines. Count them all. 4, 3, 7. Plus 2, 9. Plus 1, 10 spectral lines possible. When this mercury vapor is shined by a photon whose energy is 6.67 electron volt. Which one occurs, we cannot determine it for a single atom. But because a gas contains billions of atoms, all are possible, or billions of them. All can be seen. Last title of this section. Northern and southern lights. Auroras. Auroras. Only observed at the poles. Why are they observed at the poles? Did you think about this? Ever think about this?
Because of the
Okay, let's learn that. Okay, we need sun. Sun provides us energy. Good. Without sun, life is impossible. But sun does not provide only light for us. Sun also provides some dangerous, harmful particles because of the explosions in the sun, called solar wind. These particles are spread all around. Of course, we are around the sun, they are coming to us as well. Especially they are causing sometimes communication breakout. They can cause this. These charged particles are coming directly to the Earth. If they arrive to us, they can cause cancer, especially in the skin. But Earth has a shield protector. Earth is a magnetic field. We know that if a charged particle enters a magnetic field perpendicularly, chapter 5, section 3, it will deflect. Its direction will change. Remember circle path they do? So they're coming directly to us, but when they enter to the atmosphere of the Earth, they deflect towards the poles. But at the poles, magnetic field of the Earth is vertical. But around the equator, horizontal. Horizontal magnetic field blocks them. But at the pole, vertical, they start entering the atmosphere of the Earth at the poles. When they enter the atmosphere of the Earth, they start colliding with the atoms in the atmosphere. Which atoms are more dominant in the atmosphere of the Earth? Hydrogen, oxygen and nitrogen. They collide with these atoms. When they collide with this atom, what will happen? They will give energy to these atoms. Of course, atoms' electron will jump higher energy levels. Will not stay there spontaneously. They will go down and then they will give light. So this light which appears on the poles, which are called as auroras or northern and southern light, is because of the collision of these charged particles coming from sun with the atoms in the atmosphere. Shortly, charged particles from the sun collide with the atoms in the atmosphere, transfer energy to the electrons of these atoms, and causes them to jump higher energy levels. Because we know that excited electrons never stay there. They spontaneously go down to the lower energy levels, return the original energy levels by emitting light, emitting photon. So, because of these photons, there is a light. And because every different atom has a different color, we are going to see the color of the light coming from the nitrogen and oxygen. Two colors are dominant in these auroras. Oxygen releases green light, which is the most common color. Nitrogen releases red light. Sometimes you can see that red as well, like this. It's not continuous, not like rainbow. Just consists two distinct colors. Because there are two dominant atoms in the atmosphere of the Earth. Because each type of gas releases a unique color, the northern lights contains only a few distinct colors rather than a continuous spectrum. And these northern and southern lights can be explained by using the Bohr model only. Because we need to know about atomic energy levels, how they are. Because I think this is an initial exam question. So, northern and southern lights and auroras can be explained by according to which model of the light? Which model of the atom? Bohr's model of the atom can explain this. Bohr model is really successful, but in some ways incomplete. In which way it's incomplete? Then we will talk about this shortly, and we will finish this section. Bohr's model gave an expression for the radius of the atom. Yes, there's an equation, we didn't write it, but there's an equation. We can calculate at what radius an electron can revolve for, depending on normally the number of protons at the center, in the nucleus. There's an equation, but we didn't write it. And also, we have an equation about the energy level diagram for the hydrogen. But it's for just hydrogen. Yani single electron atoms. Bohr model is unsuccessful for studying or defining the multi-electron atoms. Unsuccessful. Only one electron, hydrogen. So many attempts were made to extend Bohr theory to the multi-electron atoms, but results were unsuccessful. And also, one problem with Bohr model is the models seem to traditional. This is changed, okay? Traditional. Traditional, because it followed classical physics in certain aspects. Yeah. Remember, I divided the Bohr model into two parts. First part, two titles, together with the Rutherford model, together they said the same thing, but later, Bohr model departed from this classical physics and went to the area of the quantum mechanics. Yani, it shouldn't happen this way. Okay, if I cannot explain it with classical physics, I go with the quantum mechanics. No, you should explain everything with classical physics or everything with quantum mechanics. This is a problem. So, the models seem traditional because it followed classical physics in some directions, and then departed radically from classical physics and into the area of the quantum mechanics. And also, Bohr model raises new questions. What are those questions? Why do electrons not radiate energy when they are in stable orbits? Why not? Rutherford couldn't explain this one as well. Bohr couldn't explain as well. But now we know the answer. Quantum model of the atom knows the answer, but Bohr couldn't explain that. And also, why electrons always have some certain stable orbits, while other orbits are not allowed. Still, the answer for this. But all these questions are answered now. But you are not going to study quantum model of the atom in this. Yes, finish.